In this video, we're going to be doing the halides. You're going to want to have table R out in front of you. So table R, keep it off to the side because we're going to need it. And this is a continuation for the table R lab. So I'm going to do one example from this page with you. They're based off of table R, so it shouldn't be too hard. I'm going to do one of the harder ones here. You're welcome. 1,2-dichloro-3-methylpentane. So the way you do these is always work backwards. Pentane means 5 in a row. So I put 5 in a row. Always connect them with single bonds to start. If you need to add a double or triple bond, you can do that at the end once everything's drawn. Now I'm going to number them. Normally, the direction you number matters, but because we're drawing it, it doesn't matter. I'm always going to be right when I draw it. If it's pre-drawn, if you're given the structure and you have to number it, you're going to have to know which side to start from, the left side or the right side, and it does matter. So if you don't know how to do that, definitely go back to the videos and rewatch that. Now, 3-methyl means on carbon 3 there's a methyl. Up or down doesn't make a difference. 1,2-dichloro. Dichloro means there's 2 chlorines, and 1 and 2 is where to find them. So there's a chlorine on carbon 1. There's a chlorine on carbon 2. This chlorine on carbon 1 doesn't matter if I put it top, side, or bottom, it's all the same. And this chlorine on carbon 2 could be top or bottom, doesn't make a difference. Add in everything that isn't accounted for to make it an H. And there it is. There's our entire structure. We double check to make sure all the carbons have 4 bonds. Chlorines only get 1 bond. Don't forget about the lone pairs, and now we can condense it. So the way this is going to condense is really simple. You're going to condense it the exact same way that table R condenses their problem. So the way I'm going to do it, carbon 1 is going to be CH2, then the Cl. Carbon 2, CH, then the Cl. Carbon 3, CH, then in parentheses, the CH3. Notice I didn't put the Cl's in parentheses, and the reason I didn't do that is because they didn't do it on table R. So if they're not doing it on table R, you don't do it when you do your problems. Now we're on carbon 4, and then carbon 5. Nope, made a mistake on carbon 4. I think I said 4. So carbon 4 has 2 H's, so CH2, and then carbon 5 has CH3. And that's it for that problem. Let's go to the next one. We'll do 2 per in this one. Alcohols. So alcohols are very similar to halides because the alcohol is an OH functional group, which is just stuck on in place of an H. Just like in the halides, the halogen is a bromine, chlorine, iodine, or fluorine that just gets stuck in place of an H. So in this case, in the halogens, it's a halogen replacing an H, and in alcohols, it's an OH replacing an H. And that's very similar also to amines that we do. It's the same idea. It replaces the H, so it's very easy to deal with. So let's do one. 2,2-dimethyl-3-pentanol. So pent means 5. So I'm going to put 5 in a row. Then I'm going to number them. I'm going to go to number 3, and that's where to find the alcohol. So up or down doesn't matter. I'm not going to draw the O, and I'm not going to draw the OH bond here. I'm just going to put it on as an OH. You can do that for these. It's totally fine. It's so common that it's become accepted. And then for the 2,2-dimethyl, well, what that means there are 2 methyl groups, one at 2, the other at 2. So 1 methyl group has to go up, 1 methyl group has to go down, and that's 2,2-dimethylpentanol. What we're going to do now is add the H's in. Remember, every carbon needs 4 bonds. So that's what it looks like when it's done. And then we're going to condense it. So carbon 1, CH3. Carbon 2 is just a C, and in parentheses, CH3 twice. Carbon 3 is a CH, and then the OH. And again, I put it after because that's how they did it on table R. Carbon 4, CH2, and carbon 5, CH3. And that's all there is to alcohols.